Okay, all right, let's start. Okay, some personal advice over here, okay, as what I shared with you before. So you want to do well in paper 2, you definitely need to do more questions, definitely. Okay, now always remember, if you can apply your concept, that means you fully understand them. Always go by this rule. If you can't apply them, you don't entirely understand the concept yet. So of course, by doing more questions, you can understand the concept better. Okay. Now there are some tips on your paper 2. You don't spend too much time on theory questions. Because theory is those kind of questions that you know. Either you know or you don't know. Okay. When the resultant force is 0, what will happen? Steady speed, at rest. Okay. Those kind of knowledge questions you must know. And you can do the questions very quick, right? Okay. But of course, calculation is the one that will be giving you more problem. So you spend more time on it. Okay. Do the drafting on the question paper itself, okay? Write anything you want. This information is given, okay? Write the formula, and then you get a better picture of the question, all right? So of course, read the question a few times, understand the question itself, think of a proper physics concept, okay? What topics is it in for the questions, okay? Formula analysis skill is what I give you guys all a while, okay? Remember what I told you? You write the formula, okay? When something goes lower, what goes up? Okay, that's very important. All right. Pay attention with the units. Okay. Units are very important. Okay. So, and also you do not need calculation to solve some questions sometimes. And you may sketch a diagram yourself. For example, some questions we might not give you the diagram. So try to draw out the diagram yourself and you can see the question better. And prefixes, okay, prefixes, normally they ask for this few things. Just make sure you understand this or memorize it. I think some of you can get it from a calculator anyway, okay? But if you prefer memorizing some of them, right? Kilo is 10 power 3 or 1000. Mega, big M, okay, is 10 power 6. Okay, milli, okay, that's not meter, by the way, it's milli, 10 power minus 3. And micro, normally they won't ask, is 10 power minus 6. Okay, so these are the few prefixes you need to know. Remember, prefixes always stick near to the unit, right? Okay, if you see the unit and you see the prefixes over there, you know you need to change something, okay? Right, so these are some of the personal advice, nothing much, okay? Most important, you still need to do the questions, okay? Now over here, these are some of the questions I picked. You've probably seen some of it before if you done some of the paper previously. Okay. So an object is released from rest and falls to earth during its fall. The object is affected by air resistance. So make sure you underline the keywords over here. So it's affected by air resistance. Okay. The air resistance eventually has a constant value. Okay, over here. So what does that tell you about the stages of the motion object? Okay. So in this case, first thing come to mind is I need to plot the graph first. Plot the graph, you can see everything. Okay. So how do you draw the graph? Remember something like this? Okay, so it will go something like this, right? So this is your velocity and this is your time, okay? So you know that as I goes up, this increases, okay? Eventually it will reach a constant value, okay? The velocity is constant, okay? Why is it so? Because the acceleration over here increases or decreases? Okay, it should be decreases. Okay, so it's decreasing over here, okay, because of increasing air resistance. Okay, so over here should be decreasing acceleration until you reach, okay, 0. All right, so the answer should be donkey. Okay, so draw out the graph first. Okay, for falling object, you need to know that this is the graph. Okay, so with the graph, you can identify even more. Okay, remember in paper 2, certain graphs you need to know. Right, and this is an example. Okay, so that's for question 3. Moving on. Okay, so moving on next, we have here. Okay, we have 2 runners. Okay, take place in a race. Okay, the graph shows how the speed of each runner change with time. Okay, now before we go through this question, let's do a bit of revision over here. So we need to know the nature of the graph here. All right. So a few things to bear in mind. Okay, let's go with distance first. Okay, and then over here we have the time. So you have a straight line over here, and then it goes down, goes straight. Okay, and then it goes with even greater gradient. Okay, so distance time graph. Okay, few things bear in mind, please. Your gradient is your speed. Okay, that's the first information you can get. Horizontal line, what does it show you? At rest, right? Okay, so constant speed here at rest and constant speed here. Okay. So these are the informations you can get from the distance time graph. Okay. Now, other than that, of course, another graph you need to know, of course, is acceleration. How do we plot the acceleration graph over here? So same thing, okay, you have distance, okay, and then t is the time. So we have two types. This is the first type. This will be the second type. So what does the blue line shows you? Okay, it should be deceleration. Do you still remember how I show you? Look at the gradient. What happened to the gradient? Now the gradient is smaller, right? Getting smaller, and I know that the gradient is my speed. So since my speed is getting smaller, I'm decelerating. Okay, that's one way of knowing it. Okay, of course, you can choose to memorize it, or you can choose to understand how the gradient works out. Okay, it's fine, either way. So if you look at this gradient for the black line, of course, it's increasing, and hence I have my acceleration. So in exam, we will need to know how to draw it, okay, calculate it. Okay, so that's for the distance time graph. All right, so that's the first graph you need to know. Okay, and then coming back here, of course, we don't really have our distance time graph here, but we have our speed time graph here. Okay, so over here, these are the informations I give you. They're asking you that at this particular time t, okay, what is happening over here? Both runners are moving at the same speed. Is it? Definitely not. Now, I know that the speed of this runner over here is this, right? If you look at the curve, the speed is here. So they are not at the same curve at all. Okay, so it can't be. Okay, runner 2 is slowing down. Nope. If you look at the curve, it's increasing the speed. So it can't be this. Okay. Runner 1 is overtaking runner 2. If you look at the area, okay, so over here, we need to look at the information of the area over here. Now, which area is bigger? The curve, right? So runner 2 must be faster than runner 1 because the area is in fact bigger, right? Just until time t. Okay, so can't be runner 1 is overtaking a runner 2. Okay, so this one can't be this. Okay, so runner 1 has 0 acceleration, not necessary. Okay, over here. The only correct answer you can see over here is that both runners are moving at the same speed. So the answer for this one is just A. Okay. Right, so let's look at this is a distance time graph, right? So now let's convert it a bit. Instead of your distance time graph, we change into the speed. So over here, same thing. It's not going to be a constant speed. Okay, it's not going to be a rest anymore. The gradient is not going to be your speed. Over here, you have constant acceleration. Over here, you have your constant acceleration as well. And over here, instead of rest, you have your constant speed. So that's the speed time graph. Okay, other than that, what else you need to know for this is the area under curve. There's something extra information you need to know is this. The area under curve is equal to the distance, total distance traveled. Now, most of the time, we will give you some known shape, okay, regular shape like trapezium, triangle, okay, rectangle. So it's very easy for you to calculate that. Just use your maths formula to calculate the area, okay? So that's for your speed-time graph. So that's it for this question, okay? So hope this one will revise you guys. Okay, over here, calculate the accelerations of the car, okay? Now, for this kind of question, please remember, take two coordinates, nice coordinates, okay? If you look at over here, okay, definitely I'm going to take the first one over here. So the first coordinate over here is what? 0, 20, right? Put it out first, okay? Now the second coordinate, you can pick anywhere you want, but I'm going to pick the last one over here. That will be 20, 30. So we want to calculate the gradient because we know that for speed-time graph, the gradient is acceleration, as what we've shown over there. So your gradient is going to be what? Y2, which is 30 minus 20 over 20 minus 0. Okay, for those with a calculator, you can press it on. So minus 20 divide 20, what do you get? We get 0.5. Okay, so 0.5 would be the answer. Okay, so over here. Okay, so this will be your 0.5. Okay, so the answer will be A. Now, sometimes you have to be careful with the unit, okay? We might not give you meter per second and second over here, okay? Sometimes we might give you hour, minutes. Make sure you change to second first, okay? Yeah, and that's for this question. Okay, so another motion time graph over here, as you can see over here, okay? This is what we've shown just now. The speed time graph is a linear graph. So it goes to show that your acceleration is constant. Okay, so which graph is it going to be look like? Okay, is it A? Or is it B? Is it C? Or is it D? Okay, of course, by the nature of the graph, I know that if it's accelerating, it's going to curve up, right? So it can't be D and it can't be B and D. Okay, but you see over here. Over here, the distance traveled is 12. And over here, the distance traveled is 6. So how do I know which? Very simple. Calculate the area on the curve. Okay, this question is slightly more difficult because you need to use two concepts over here. So the area, definitely, you have half times 4 times 6, right? Area of a triangle. Okay, 4 for the horizontal, 6 for the vertical. So you will get 12. So the total distance traveled will be 12. And hence the answer will be A. So over here, you need to apply two concepts. First, the curve itself, the shape of the curve. Second, the total distance traveled from the speed time graph. Okay, yeah. Right, that's how you solve this question. Okay, so most important, you're able to know everything over there. All right, you need to know the nature of the graph. Okay, calculations. Okay, and this shouldn't be giving you much problem. Okay, the next concept we'll look at it is density. Okay, so density over here, first thing come to mind is density is equal to MOV. So that will be mass or volume. But be careful with the unit. Look at what happened to the unit. This is not kg per cubic meter. This gram per cubic cm. But I know that over here, all the dimension given over here in the questions is already in cm. So I don't have to bother changing the units at all. So let it be, okay? So volume of a cuboid, you should know. Length times height times your weight, right? So this, and how much do you get? 2 times 2 times 10. That gives you 40, right? Okay, 40 cubic cm. Okay, so what's the mass? Okay, so density, let's apply here 2.5. Your mass is something I need to find out, and then your V is 40. Okay, so over here, if you move over, your mass is equal to 2.5 times 40. And you'll get 100. Okay, so it's 100. Okay, so very simple. Okay, look at the formula. Make sure you don't screw up the formula. It's density equal to mass over volume. Okay, so moving on. Okay, question like this, okay, is a favorite asked question, okay? So you already know that the increment of the volume is the volume of the immersed subject, okay? In this case, a stone. Okay, over here, so what's the volume of the stone? So the volume will be If you look at here, it's 40 to 65, right? So just take 65 minus 40. So we get 25. And what's the unit? Cubic cm. So what about the mass? The increment of mass is the stone, right? Because after you put the stone, the mass increase. So the mass will be 217.5 minus 105. Okay, let's see how much you get once. So if you minus it accordingly, you should get 112.5. Right. Okay. So density, okay, needless to say, mass over volumes. Okay, your mass is 112.5, and then over 25, and we'll get 4.5. Okay. So over here, the unit is quite consistent because I'm using gram and cubic cm, so answer will just be C. Okay. So these are kind of favorite asked question and in paper 2 especially. They won't ask a lot in paper 4 for density, but paper 2 definitely. Yeah. Okay. All right. So moving next, we have force. Okay. Now regarding force, you already know that F equal to ma. Okay, this is what the textbook gave you and most of the book give you. Okay, for me, if you know the way I don't really use this, I prefer this. Okay, it's kind of same, just that want to give you an impression that there could be more than one thing on something. So the sigma notation over there is to tell you that there is more than one force. Okay, so let's take a look how we can use it. So let's look at one example. Okay, so we know that. Now this is not just any force, we call it a resultant force. Very important to classify as resultant force. Because if you still remember, resultant force is basically the summation of all the force. We need to simplify all the forces into one, basically. That's what we're going to do, okay? Now, for example, if we have this, and we have some forces acting on here, maybe we have 10 Newton here, we have 30 Newton here, and maybe we have a 20 Newton acting here. Okay? Now, there's a lot of forces acting over here, right? So we can't just put all the forces over here. We have to simplify it first. So there's one way what we're going to do is that we get the resultant force. So over here, what we want to do is that we get 30. So your sigma F is basically 30 plus 10 and then minus 20. Because your right force is 30 plus 10, right? And then your left force is 20. So if you sum them up together, you should get 20 Newton. And hence, you can simplify from this into this. They are the same. Okay? That's a good thing about resultant force. You can simplify it. All right, so hence we have this formula. Okay. Now, other than that, what else you need to know is that remember that velocity is a vector as well. Okay, be mindful with putting the sign. Now, remember this rule. If your object is moving up, or it could be moving right, make sure that your velocity is positive. Okay. Now, if your object is moving down and it's moving, or it could be moving left, make sure it's a negative. Okay. So important for you to put negative for objects which are moving to the left. Okay. Now, this is to ensure that the value you get is correct because we know that velocity is a vector. So vector, we're going to define the direction using sign. We can't, of course, you can also say that velocity moving to the right, but mathematically, we need to add some sign to it, positive sign or negative sign. Okay. So let's come back to this question. Okay. Now, whenever you are dealing with a question like this, okay, for certain students, okay, you might get confused. Lots of information is given to you. So what you want? You list out all the information. So the informations one they give you is 50 kg. List them out first. M is equal to 50 kg. Accelerate means to say you speed up from 2 meters per second to 10 meters per second. So U, my initial speed, 2 meters per second. Okay. V, my final velocity is 10. So try to write out first, okay? Write out first, write out all the information given to you, and then what they want you to find. They want you to find what is the impulse. Impulse is what? Ft, if you still remember. Now, impulse is also known as change of momentum. They are the same thing, different name, same thing, okay? Over here, you have to look at, okay, I want to calculate my impulse, Ft. Should I use Ft? You can't, right? You don't have the force. You don't even have the time. So I can't be using Ft, but I do know for a fact that Ft is equal to mv minus mu. Do I have my m? Yes. Do I have my v? Yes. Do I have my u? Everything is there. Okay, so you're just gonna put in. So you want to factorize it, no problem. Okay, you can factorize the v. Okay. Now, since both of them is moving at the same direction over here, can you see? Okay, so you can just put so both should be positive. Or you want to put both negative, fine. Okay, to ensure that they are moving in the same direction. So you have 50, 10 minus 2. Okay. So 10 minus 2 times 50 is 400. Okay. And the unit is Newton second. But do you know that there's another unit? That could be kg meter per second. Because I know that impulse itself is also the change of momentum. And what's the unit for momentum? Kg meter per second. Or you can write Newton second. It's fine. They have the same thing. Okay, I see some of your paper, some of you put Newton second, it's fine. Okay, for the momentum, no problem. Okay, so that's for this question, okay? Okay, moving to the next question about weight, okay? Moving at the A terminal velocity. First thing comes to your mind is that this is moving at terminal velocity. So terminal velocity is basically constant speed. Okay, it is a constant speed. And then there's a wind exert a horizontal force of 0.5 from the left. So there's a wind coming from the left to the right, and the magnitude is 0.5 Newton. Okay, so if you look at this, okay, so let's see. So first thing, I know that W is going down. That's my weight. Okay, second, I know that the wind is blowing here. Okay, this is W. By the way, W is weight. Okay, over here we can filter out first. Okay, this one sure wrong because of 1.2 Newton going down, right? So, and I know that this one and this one, okay, so over here, right, the answer is C. Why? Because it says that this ball is falling at terminal velocity. It means to say this thing is falling with constant speed. Now, there's one way where object is moving with constant speed, which is the air resistance equal to the weight, right? So basically, if you look at the object, the air resistance, okay, is equal to the weight. And since I know weight is 1.2 Newton, so the air resistance must be 1.2 Newton as well. Okay, so it balances up. So what's the resultant force? Now, since the upward force and the downward force balance each other, and then I know that suddenly there's a wind force coming from the left side. So the answer is C. So that's my resultant. Okay, so the answer is C. Slightly trickier, okay, because a lot of students miss this part. They miss the terminal velocity part, so they get it wrong. Okay, so that's for question 7. Any question at the moment? No. Okay, moving on. Okay, over here is what I try to show you just now. Okay, remember what I say? Object moving right, positive. Object moving left, negative. Okay. Of course, you can choose to put the other way around, but by the time you go to A level foundation, most of the university and the colleges, they they put the right direction as positive. Okay, so if I'm look at here, my U is positive 25 because you're moving right. My V is negative 40. Now, most students, you didn't put the sign and you don't get it right. Okay, so this is why it's very important for you to put the negative sign. Okay, so over here you put the negative sign. Okay, they want to okay, let's list all the information given first. Okay, the time, okay, millisecond, although this one looks a bit funny. It's not meter per second, okay, that's millisecond. So millisecond, if you put in the calculator, prefixes 50 divided 1000, so that'll be 0.05 seconds. Okay, so what's the information they give us? Oh, there's a mass too. Write out the mass. So I have all the information given. So can I calculate the force? Yes, you can. If you still remember the formula that I give you guys, okay, the formula paper. Okay, if you refer to it, you should see this, right? So this is a formula you should use. Based on this information given, the most suitable formula to be used is this. Okay, so you just put it in. So 0.06 times your minus 40, then minus 0.06 times 25. Okay, and then over, kind of write everything down there. Okay, and then divide by 0.05. Okay. Put in your calculator. You should get negative 78. Okay, so the answer is donkey, but you probably think it's funny. How can I get negative? What is the meaning of negative? Now don't worry about negative. Negative is just, now remember, force itself is a vector quantity as well. Okay, so force, since it has it's a vector quantity, so the negative is to tell you that the force is acting to the left side or right side? The left side. Which makes sense, right? If you look at this ball over here, okay, the force is the force exerting on the ball itself is to the left side. Otherwise, how can it be moving to the left at the final stage, right? Okay, so that's the logic of it. But IGCSE, yes, we don't emphasize a lot on the negative sign. Okay, so you may just put positive sign. Okay, remember the technique, very important. Okay, this technique is important. Why? Because you can use it in your physics study later on as well. Okay, so yeah. Okay, moving next, we'll just go through a bit more here. Okay, let's see over here. All right. So, okay, just to save some time, let me just jump a few questions first. Okay, let's talk about the moment. Okay, you probably learned from me already, the moment. Okay, just going to show to the rest of the students. Now, in the textbook, you probably see different method. Okay, so few things here you need to be aware of is, okay, let's just write out first. Let's say I have F1 over here. Okay, then over here I have F2. Then over here I have F3. Then over here I have my pivot. Then over here I need to label all the distance over here. From here to here is X. Then from here to here is my Y. Then from here to here is my Z. Okay, how do I form my equations? That's the most important. Now, remember, there will be another force acting over here too. Okay, but most of the time we don't really. But just to write out. Actually, there's another force over here. Now, remember the pivot itself. There's another force. Okay, sometimes it could be going up. Sometimes it could be going down. Okay, I just put F0. Okay, but let's say it does not exist for now. Okay, just to simplify our calculation. Okay. Now, how do I form the moment equation? Okay, if you learn from me, you probably know that my favorite method is this. The moment clockwise is equal to my moment anti-clockwise. That's what I do always, right? So, of course, I don't really like to write a lot of words, so I just put MC equal to MAC. Okay, Now, what's your objective next? Your objective next is to see, hey, who is giving me clockwise? Who is giving me anti-clockwise? So the center is here, right? So this is my period. So if I look at F1, you are rotating in this manner, and that's anti-clockwise. Okay, so that's anti-clockwise. So we should be putting the other side. So that'll be F1 times X. Because if you remember moment is the force times the distance. Okay. Now let's look at F2 now. F2 is giving you what? Okay, since it's going up, it's giving you a clockwise moment. So over here, you put it in. So over here, you have F2 times Y. Okay. Now over here, how about F3? F3 is giving you a clockwise moment as well. So over here, F3 times Z. So this is how you form the equation over here. Forming the equations, and then you put whatever information they give you in the questions into it. Okay, and that's how you get your answer. Okay, so that's it. Okay, so this is a method. Let's go back to the questions. So over here, we will look at these questions. Okay, wait, is there another one? Okay, never mind. We'll go with this. Okay, now over here is a bit tricky. Do you see that a uniform beam of XY is 100 cm long? Okay, and the weight is 4 Newton. But you see something very funny. The 4 Newton is not labeled in the diagram. So you have to label it yourself. Okay, that's very important. So, which is why you need to read the questions carefully. And I know for a fact that the center of mass must be here. Oops. Okay, I bet here. So that's my, oh, how much is that already? Wait, give me a moment. 4 Newton, yeah. Okay, so this will be 4 Newton. That's the weight of the whole thing, the beam, right? So same thing, we're gonna look at the equations that are used, okay? MC equal to MAC. Okay, so we look at one by one. 8 Newton is going down, and then the F is going down. Okay, so if you look at here, so this 8 Newton is giving you what? The pivot is here, by the way. Okay, so I know that 8 Newton is going down at the left-hand side, so it's counterclockwise. Okay, counterclockwise, so you're going to put it here. So that will be 8 times. What's the distance from here to here? So that'll be 70 cm, right? 10. If you want to change to meter, it's fine. You want to, so that would be 0.5, right? Because 60 cm here, 10 cm here, so that would be 50 cm here. Okay. All right, and then next, how about the 4 Newton? The 4 Newton, of course, still anti-clockwise, 4 times. How long is from here to here? Okay, so I know that the whole thing is 100 cm, right? So I know that from here to the center of beam is how much? Here, over here. So that'll be 50. Okay, so if you look at here, since it's 100 cm long, it's 50 over here and then 60 over here. So this one should be 10 cm as well. Okay, so this one is 10 cm. And then of course, F is giving you a clockwise moment. Okay, definitely. So that will be F times. Over here is 80 and 60, so it's just 20. So that's how you form your equation. Okay, put everything inside and you see what you get. So 8 times 50 plus 4 times 10, divide 20, and you will get 22. Okay, okay. So that's how you get your equation. Get the equation, solve it, very easy. Identify who is giving you clockwise and anti-clockwise. Okay. Of course, if you can kind of do this kind of thing, the exam also can, if you want to visualize it. Okay, but the trick is still this. Okay, sometimes we will not label the force for you. You need to draw it out. You need to label it yourself, should it be necessary. Okay. All right, so that's for the moment. Any question at the moment? No question. Eden, any question? No. Okay. All right, moving on. Okay. All right. Wait, give me a moment. Okay, momentum kind of questions, normally they won't ask in MCQ from my experience. Okay, but I mean the easy one, yes. I mean I'm talking about the hard one, the M. Okay, never mind. Let me write out the equation first. Formula, okay, if you still remember, the momentum is what? So the momentum is, okay, there'll be three cases that you need to be aware of. Okay, it could be M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. That's the first one. I mean, this is a general equation, okay? Now, how do I want to simplify it is, now imagine you have two objects after colliding with each other, it's moving together, okay? Now you can simplify this to this. Okay, since they are moving together, you can combine them as this. Because when they're moving together, they are one big object. So that's M1 and M2. Okay, let me just label it out first. And since they are moving together, we don't really need V1, V2. We just put them as V. Of course, you can put V1 also again. Okay, so that's for this case. Now for the second case, which is very rare, is this. Initially, they are together. Okay, this is the initial. Initially, think about a gun and a bullet. Okay, initially the gun and the bullet is not moving. But upon firing the bullet, you will see that the gun going backward, the bullet moving forward. Okay, that's a kind of explosion, momentum. So initially it's this, and then after that they move at different direction. Now for this kind of question, what you need to know is this: my M1 U1 plus my M2 U2, right, is equal to M1 V1 plus M2 V2, right? Remember, this thing, right, is zero initially because the initial momentum is zero. Why? Because they are not moving in the first place, right? So since they are not moving in the first place, it's zero. That's for this case. Okay, explosion kind of question. Okay, when you explode, things moving in opposite direction, then you have this case. Okay, so that is the equation. All right, so work here. Okay, if you look at the questions, a bullet, okay, strikes a wooden block, okay, stays in the block, and then what's the speed of them moving together? So I definitely know that that is for the second case, right? So I'm gonna write out first M1 U1 plus M2 U2 is equal to M1 plus M2 V. Because upon impact, they are moving together. So it's the second case. So let's put the information inside 0.1. That's for the bullet, yeah. Moving at the speed of 600. Okay. Plus, okay, the M2, which is the wooden blocks, which is not moving at all. Of course, you can put 0. Okay, sub it in 0. And it's equal to the M1, which is 0.1 plus 1.9 V. Okay, that's how you form the equation, and that's how you put the information inside. And what do we get? 30 meter per second. So that's it. So both the bullet and the wooden block is moving at 30 meters per second. Okay. Of course, memorizing is one thing. This thing you need to memorize. But it's very easy to memorize. You know why? Because this thing is just, oh, I did not put it here. So this is just initial momentum. Okay. This is initial momentum. And this is your final momentum. Kind of like conservation of energy, you know. Okay, conservation of energy, you still remember, is initial energy equal to final energy. Okay, so that's how it looks like. Okay, so that's the for momentum. Okay, you will see more momentum question in paper 4. You won't see them a lot in especially conservation of energy. Okay. Okay. All right, over here. Okay, so take a moment and read the question first. Okay, so The stone gained 10 joule of gravitational potential energy. I shall write my GP. GP stands for gravitational potential energy. So let's say initially I'm starting with 0. Okay. So I gain something over here. How much I gain? I gain 10. So just label it out first. Label so you can see better. The stone has a kinetic energy at Y. Okay. So the kinetic energy at Y is 2. Okay. So how much kinetic energy did the stone immediately have after it threw at X? Okay. So according to conservation of energy, energy are conserved. What does it mean by conserve? Conserve means to say the total energy remains the same. But just as some of the energy change from one form into another form. In this case, definitely it changed between KE and GP. So I know that X is how much? So I know that the total energy over K is how much? 12 joule, right? Okay. So it's 12 joule over here. So I know that initially it's not at the ground level. So GP is 0 because at the ground level, okay. So I need to provide 12 joule as well. Okay. So the total energy here must be 12 joule. Okay. So as you can see, initially I have 12 joule of kinetic energy. As I move up to Y, okay, the kinetic energy itself is changing into gravitational potential energy. Okay. So this is your starting point and this is your final. Okay. Your final state. That's it. Conservation of energy. Very simple. Okay. Remember, total initial energy equal to total final energy. That's what we mean by conserve. Okay. Okay, moving next. Okay, it should be simple, right? Question like this. Okay, remember formula for power is what? Okay, work done over time. Okay, work done is basically just force times distance. But in this case, there's no, the force is basically your weight. Remember, your weight is a force too. Okay, just put everything together. 2000 times 2 over 0.8. So that's is 5,000. Okay, same as that. Use the formula, stuff it inside. Everything is SI unit, so you can put it inside. Newton, meter, second. Okay, very simple equation. If you know the formula, definitely. Okay, moving next here. Okay, so okay, you can read the question. Kinetic energy of the lorry equal to the kinetic energy of the car. So what's the kinetic energy formula? Half mv squared, right? Okay. So I know that for the lorry is half m. What's the mass of the lorry? 4,000 v squared. So equal to half mass of the car is 1,000 and then v squared. So can I calculate the velocity of the car? Because since they say that, oh, the KE of the car is equal to KE of the lorry, right? So, okay, you put everything in the calculator, move around, that's just your mass. You should get 8. Okay? So 102 to the power of mathematically is possible. Okay? So, okay, so this is a kind of question. Okay, make sure you know, sometimes you need to know how to place the equation. So your math skill are very important. Your algebra, okay, rearranging formulas, things like that. Okay, make sure you know how to rearrange. Okay, so your math skill is vitally important over here. Okay, efficiency. Okay, this question is about efficient. Okay, how efficient is these systems? So over here, the motor is 40. Okay, so I know that efficiency is what? Efficiency over 100%. Okay, I divide by 100% already. It's equal to the power of the useful over the power total supplied by the system, right? So the efficiency is 20 over 100 because that's what they say. Now the motor is 40. Okay, the motor itself is 40. But I know that the motor, the useful and power should be the power that used to give the gravitational potential energy to the systems, right? So I know that the motor is my total. So can I calculate the useful power over here? Can, right? Use the equation. So my useful over here is 20 over 100 times 40 is 8. So, but I do know that how long does it take? So now my power is 8, right? And I do know that power is what? how is work done over time, right? Work done is what? Weight times distance traveled over time, right? So if you put all the information, your weight is, did they say the weight? Oh, the weight is 40 over Q. So that'll be 40 times 0.5 over the time, which I don't know how much, is equal to 8. So you put the information inside, okay? So what do you get? 40 times 0.5 divided 8. So you should get 2.5. Looks simple, right? Okay, but it might not look simple from a point of view, because for you students, you might need to think of what is the appropriate formula to be used first. So you can see this question is tough because I need to use 2 formulas. And it takes time, okay? All right? So try to spend a bit more time on this kind of question, but depends. You can choose to solve other questions first, then you come back to this question at the end, okay? Yeah. Okay, so moving next. Okay, pressure, of course, it's rho GH, right? Okay, so, but I just want to let you know something over here, which is more important. Now imagine you have an object over here, okay, and this water, by the way. Okay, so over here. Now, over here, there will be atmospheric pressure, okay? P-atm is atmospheric pressure, but okay, just P-atm, I just wait P-atm for space. Sometimes they will give you the value itself, so you don't really need to memorize, but most of the time they give you is around this 100,000 Pascal. Now, what I want to tell you is this. Now, this object is subjected to both the atmospheric pressure and the water pressure. Okay, but the correct term is hydrostatic pressure. Okay, over here, maybe your rho GH. Okay, let's get this water out of the way first. So this part is rho GH. So you need to know that the total pressure exerted on this object, right? Okay, let's say this object is your atmospheric pressure plus rho GH. This is an important formula. You need to pay attention. It will ask in favorite ask question in paper 4. Okay, 2 things you need to include over here. Because the pressure is coming from the air molecule, which is atmospheric pressure. Other than that, I still have the weight of the water that pressing against this object. So that's the hydrostatic pressure. So 2 of them. So you need to add them together to get the total pressure. But sometimes I might ask you, calculate the pressure by the liquid itself. Then you know it's rho GH. It's not going to be the total pressure, definitely. Okay? So, over here. Okay? So over here, what's the pressure exerted below the dam over here? So, right, moving next. Okay, as I was saying that, see over here, it said due to water. So I don't have to worry about the atmospheric pressure anymore because I'm just interested in the pressure contributed by the water. Okay, so it's just rho GH. Okay, your rho is density of water is 1000. Okay, G, sometimes they give you, sometimes they don't, but you already know the G value, right? It's 10. And the depth is the H, which is 65. So you multiply inside 100, I mean 1000 times 10 times 65. You should have 650,000 Pascal. So the formula itself over there is more important. Okay, that is what I want to share with you. But okay, a barometer. Yeah, very important barometer. Few things that you need to know. Here is vacuum. Okay. Second, how do we measure atmospheric pressure? It's according to this formula, rho GH. But that's not water, that's mercury, by the way. Mercury has a denser density. The density is higher. And the H that we should be using is from here to here, remember? This to this. It's from W to X. That's the H given here, okay? And you will see that the H given here, right, is 660 millimeter Hg. Hg is the symbol for mercury, by the way, okay? So it's fixed already, okay? And that's how we can calculate the atmospheric pressure. The density of the mercury, we know the G is 10, and then the H, most of the time is 760 millimeter. And of course, you change to meter yourself, So it's just 0.76 meter. Okay. All right, so that's it. Okay, all right, I haven't answered the question yet, my bad. Okay, the atmospheric pressure itself is increasing. Okay, okay, now since we have the basic of a barometer, now I'm going to increase the atmospheric pressure. Okay, maybe suddenly there's an increment of air molecules in the atmosphere. Okay, so then what will happen? Of course, it will be higher, right? So what distance will increase? Okay, so let me see. VW, nope, VW, okay, never mind, let me draw the thing first. Now, theoretically speaking, if the pressure increase, right, wait, my bad, it should be Q. This thing should be taller. The height will be taller, okay? So VW cannot be increasing, say goodbye to that. WX, WY is increasing, yes, because now your new Y is Q. X, Y cannot be because XY is fixed already. It's not changing. XZ also not changing because it's at the bottom already. So the correct answer is W1. Okay. So this question is trickier in the sense that you need to have the fundamental of barometer first. Okay. All right. Okay, that's it for this question. Moving on. Okay, a manometer. Now, for manometer, please bear in mind, this is a formula. Okay, I always show you guys the gas pressure equal to the atmospheric pressure plus rho GH. Okay, and the difference, the H is basically this, the difference of height, this thing. And then the atmospheric pressure is acting here. So that's how a manometer works out, okay? So you apply the gas pressure over here, of course, this thing will goes down, right? Okay, initially, let's say the water level is balanced, okay, it's the same. But because of the high gas pressure over here, push this thing down, and it will form a differential height, and that's H, okay? So with the differential height given over here, okay, and what did they say? There's a gas leak, okay? So the pressure is lesser already, of course. Since the pressure lesser, I expect that this thing will go up a bit. If this thing goes up a bit, this thing go down a bit. So since the pressure is lesser already, right, I cannot press it down more, right? So it kind of go down like this, right? Make sense? Or maybe I start to be taller. Okay, initially it's like this. So the pressure on this side is lesser, it will go down. Okay, so the water level at P rises, while the water level at Q fall. So now it's C. Visualize it, very easy to understand. Because high air pressure or high gas pressure will push the thing down. So the water level is lower. So it's not that difficult if you imagine it, okay? Not much concept, okay? Just at the calculation, I want you guys to know this. This is a calculation for manometer. In this case, to be more precise, it's a U manometer, okay? All right, that's it, okay? So, all right, we settle two more. Wait, let me take a look at this. Okay, so, okay. Okay, this calculation, I think you can do it yourself. This one, not so important. I'll just show you this one. Now, for this kind of technique question, right, okay, I just want to show you this technique. Okay, the pressure due to the water at this depth, P, another day, okay, fresh water. So one is sea water, the other is fresh water, okay? Now, few things, please write out the information first. Okay, the density of the sea is 1.5 times definitely the density. So you can do this, rho C is equal to 1.3 times the rho of fresh water. Maybe you put F, rho F. Any symbol is fine. Okay, and then I know that the P is the pressure at the sea, so that will be rho GH, right? Rho C and then G and then H. So rho C and the G is 10, right? And the H is 20, from the information given. So 10 times 20 is 200. Rho C. Okay. Now over here, I can convert it this way. 200 rho C is 1.3 rho F. Because that's the information from here, right? I can apply to here, right? Okay, so once I have that, what can I do? And then the other one is the pressure due to the fresh water. Maybe I put P nu. So the P nu is how much? The P nu is the density of the fresh water. okay, times the G, and then times the depth, which is 26. Okay, so since I know that the G is 10, so 26 times 10 is 260. So 260 is F. Okay, now over here, what you can do, okay, I don't have enough space over here, so I just write it here. Okay, I'll just write it here. So mathematically, right, this thing, okay, if you look at here, we already have this thing, okay, 200 times 1.3, this thing, right? Okay, this initially. Now the new pressure that we need to figure out is 260, this one, right? Okay, so how do we simplify this? Very easy. You just take this, divide this. It's a mathematical way, right? You take this, divide this, and you can cancel some of the things over here. So 200 times 1.3 divide 260, that's just 1. So this is 1, cut 1. So P over P new should be equal mathematically. So that's how we prove it. So the new pressure should be equal to the initial pressure. So the answer is B in this case. Okay, so that's for this question. Okay, so that is a technique. Okay, so remember this kind of mathematical technique you need to apply, because I will employ this technique again on the resistivity of the wire too. Okay, remember this technique. Okay, I'll jump a bit of the chapter because I'll go through this just to make sure we have time to cover the most out of it. Okay, so now we will jump to magnetisms and electricity first. Yeah. Okay, over here. Now remember the difference between electromagnetic and magnetic is they are the same thing, but there's something different you need to know about it. Is that the inside the electromagnetic, right? Okay, or the solenoid also known as, okay, there will be field line inside. Can you see? Over here inside, there's some field line inside here. Okay, so that's the difference. But and other than that, you can see that the magnetic field is the strongest inside the electromagnetic because they are very close together. So remember, when the field lines are close together, it's an indication that they are strong. So yes, so that's one thing to know about. Okay, so for this question, okay, so what I do is that I increase the voltage. Of course, you increase the voltage, your magnet is stronger. Now, since your magnet is stronger, it should be closer. Okay, remember the separation of a line indicates the strength of the magnet, right? So basically, and the direction is reverse. Okay, since the direction reverse, the polarity reversal. So meaning to say, hey, initially it's north pole, south pole here. Now, since you change the direction of the current, your north pole is here, your south pole is here. Okay, so it should be A. Okay, so the lines closer together is an indication of they are stronger now than before, and the right hand side is your south pole. Okay, all right. So that's on the electromagnetic solenoid. Okay, now moving next here. What magnetic pole is induced at X and Y? Okay, now iron bar. Now remember, this is a magnetic material. So this one, it will induce a south pole here, north pole here, south pole here, north pole here, and this thing will be attracted to it. Because it will induce, this magnet will induce a magnetism in the iron bar in a way it attracts it, right? There's one way it could attract it is that opposite polarity, right? So this one will be a north pole, this one will be a south pole, and they will attract. Okay, so the answer is north and north. The answer is A. So that's for X and Y. Okay, so moving next, this thing. Okay, so this is not so important. This one. Now remember for magnetic material, right? Magnetic material, you just have to memorize a few examples. Magnetic material, there's only a few of them. Okay, there's iron, there's cobalt. Oops, wrong spelling. Oh, but you get the idea, right? Cobalt. There's nickel, and there's steel. Now, steel is something you can use to make permanent magnet. Remember, steel can retain magnetisms. You say that after you magnetize the steel, right, the magnetisms in the steel will remain. So this is why we can make them into permanent magnet. Okay. So in this case, what is a possible material? Okay. So the fish Can't be aluminium. Aluminium is not a magnetic material. Remember, not all metals are magnetic. Yeah, so it should be soft iron, and the root, since it's a magnet, it should be steel. So the answer is down. Okay. So steel is a material for permanent magnet. A knowledge-based question, so you should be able to solve this quick. Okay, next. Electrical circuit, yes. Okay, yeah, this is something I need to draw on the graph. Draw the graph first. Okay, a very common asked question. Now, for the graph itself, let's go with V and I first. So V is your voltage, I is your current, okay? Now for filament lamp, right, you will see something very funny. Okay, this is what we call autonomic resistor. What's the meaning of autonomic resistor? Autonomic resistor means to say it obeys V equal to IR. Means to say that it's directly proportional. But you can see that for filament lamp, right, it's not the case. For filament lamp, it's gonna be a curve. Filament lamp, it looks like this. This thing will be going up. This is for filament lamp. Okay. Now, why is it so? Very simple. Gradient, same concept again. Now, of course, V equal to IR, right? So the gradient is what? The gradient is the resistance, right? Mathematically speaking, V is my y-axis, I is my x-axis, and R should be my gradient. So you can see the gradient is higher as your current increases, which makes sense because if you learn the theory itself, the higher the current, the hotter it is, and therefore the resistance is higher. Okay, so that's how we have this graph over here. But the problem is this: they don't like to ask V against I graph. They like to go with I against V graph. Then how does it look like? Okay, now the autonomic resistor is still the same. It's still gonna be a straight line. Okay, autonomic resistor means to say that the resistance will never change. So it's gonna be a straight line, but how about for the curve? How about for filament lamp? Something funny here, it will look something like this. So this will be a filament lamp. Okay, that's it. Just inward only. This one, right, it goes up, okay, because the resistance, okay, the gradient is the resistance is higher. But if you flip the axis, the I and V, you will get the curve is going down. That's it. That's the difference. But the second graph is what they like to ask you. So my idea is that you memorize, not really memorize, you memorize the first one. And then if they ask you, hey, the graph is IV, right? Then you just flip it over. That's a very important tips, okay? All right, so if you look at here, cannot be this, okay? So this is autonomic resistor, okay? Autonomic resistor, so this one is wrong, okay? And if you look at the filament lamp, okay, we did give you an example. Since this is current against voltage, we will look at the second example. The curve should be this. So the answer is B. This is what I would like to emphasize on, okay? So you memorize one, you memorize a V against I, you can easily know the I against V because it just flip over. Okay, that's it. Very simple. Okay, now over here, right, is what we call a change of analysis. I don't know why I call that, but basically this is what I do. Now over here, see, I have a variable resistor and I have a fixed resistor. Now over here, I decrease the variable resistor. Let's say this is R1. Define yourself, it's fine, no problem. This is your V1, this is your V2. Define the variable yourself first. Anything you want is fine. Now over here, based on the question itself, see, use this method. So I know that R1 is decreasing, right? That's why you say the variable resistor is decrease. Now according to chain of reasoning, Okay, as I show you guys, the lower the resistance, what happens to the voltage across the resistance? The low resistance should be lesser also, right? Because you don't need so much energy there. So the V1 should be lower as well. You see, that's a change, the kind of like a chain of reasoning. Okay, so my V1 decreases. Okay, so what happened to my, okay, R1 is not going to change. Okay, R1 remain the, I mean R2, sorry, R2 is remain the same because of fixed resistor. What about your V2? Your V2 should be higher. Why? Because I know that EMF, the voltage from Q, right, EMF, right, is equal to V1 plus V2, right? Now, EMF is not going to change, right? EMF is still constant, okay, because it's a voltage from the battery. So since your V1 decrease, your V2 must increase. So V2 will get more voltage. So this is how you do your chain of reasoning. That's the method I show you guys. Very simple, right? No calculation is required. All you need is just write something like this, okay, and then you can know the answer. So the voltmeter P must decrease because it's for P, and this is for Q. So one low, the other high, decrease, increase, so the answer is B. Simple as that. Do your chain of reasoning, and you can you can do the question easily. Okay. All right. So that's for this question. Moving next. Okay, parallel circuit. What is a combined resistor? Okay, use the formula. If it's this one, we're going to settle this one first. So remember the formula? Okay, because it's a parallel, right? I'm going to combine this parallel resistor together. Okay, so if you use the formula, that'll be 1 over R1 plus 1 over R2 is equal to 1 over R. Okay, just put in your calculator. You should get the answer is 4. Okay, put in your calculator, get it 4. And now, I know that this is 4. The total is 4. Now, I know that I can redraw the thing. In fact, you can draw this. Oh, now since I combine these two, is 4. And then there's another 6 over here, right? I still have another 6 over here. Can I add these two together? I can add these two together, right? Yes, I could. Add these two together, you get 10 ohm. Because for series resistor, you add them together. Okay, so the answer is boy. Simple as that. Okay. So remember the formula. All you need is remember the formula, okay, for combining parallel resistors as one. Okay, so that's the formula. Okay, moving next. What else we have? Okay, over here, over here, something else over here to realize. Okay, so this is a question. So, okay, over here, right, we need to cancel some circuit first. Okay, so since this one is blocking, okay, nothing here, blocking, nothing here, nothing here. So this one definitely not the answer because there's no current flowing because the diode is blocking it. So this one is blocking here. Okay, so if you look at here, right, which one gives you the highest current, total current, to be precise? Okay, now remember, parallel circuit, just a knowledge base, parallel circuit will give the lowest total resistance. If you calculate the formula accordingly. So which one is parallel? This must be series because the current is flowing from here to here. This is a it's a series circuit. This is a series circuit also is flowing from here to here. So which one is parallel? This one, right? Because I can flow from here to here, I can flow from here to here. So parallel circuit will give you the lowest resistance. By giving lowest resistance, I can have the higher current, high current. Okay, the I increases for this case. Okay, so these are some. You see, there's no calculations required. I mean, you can do it. I mean, you can use 1 over 2 plus 1 over 3 equal to 1 over R. You calculate yourself. You can go do a calculation, but it's not necessary. You definitely you can calculate. You get the current share lowest one. Okay, but since you have the basic knowledge, you save a lot of time. Okay. All right. So we do it the smart way. So remember, parallel circuit always give you the highest current. Highest current because it gives you the lowest resistance. Okay, that's it. All right, this is the kind of questions that students face a lot of problem. Now, this formula is not compulsory to know in IGCSE, but for me, the way I teach my students, all of them need to know it. Because it's a method I'm going to show them. So if you look at here, resistance. is equal to resistivity. That's not density, by the way, that's resistivity. Times length over area. Now, area, most of the time is just pi r squared because wire, the area is what? It's a circle shape, right? So you can put pi r squared. Or you can put pi d over 2 because diameter over 2 is still the radius. You can do this, you can write out, okay? But we're going to look at the question. Okay, come, let's look at the question first. Okay, how do I apply this formula? Oh, look at, okay, I will show my steps at the whiteboard there. Okay, so over here, if you look at the questions, okay. All right, so I have to look at that. Okay, so over here, the resistance is R. Okay, R. Okay, the length, okay, of course I use that symbol. Why don't we just follow it? Okay, the resistivity times this symbol. Okay. And then he said that the diameter is D, right? But I need radius, so I know that it's gonna be pi D over 2 squared. Okay, now over here, I just simplify it. Okay, this is just maths. Okay, so you should have something like this. And we simplify it, you should get for this. Just basic maths only. Do it this way first. Okay, over here, next he said the party now is more into a cylinder of this thing and the same volume. That's the clue. Same volume. Okay, now this question is slightly tougher because of the nature of the questions. He said that the volume is the same. Okay, so your V1 equal to V2. The initial volume is equal to the final volume. So what's the volume for cylinder? Pi r squared h, right? Yes, I have to answer that myself. So pi r squared h. Okay, radius d over 2. Okay, now for the final volume, what did he say? Okay, of 2d. So it's pi 2d. Now the diameter is 2d over 2, and then square. And then the new length, I don't know, I just put L new. Is it okay? Just write out. Okay, now your objective is to basically simplify this whole thing. You're gonna cut this out. Okay, so this one squared out, you have d squared over 4, this thing. Okay, so divide, just d squared L new. Cut, and you should get your new length is equal to 1 over 4, this, the original length. Simplify it. Just maths only, simplify the thing. A lot of mathematical skill to be used over here, okay? Simplify to this first. Now, okay. How about here, I just use R1. So R1 is the initial resistance, by the way. So R2, okay, same thing, this thing. Okay, R new over pi, the new diameter, which is how much? Okay, 2d, but I need radius, so I need to divide 2. So this one, you simplify it, 2 cancel, so you have this L new over pi d squared. But do you remember, okay, this one, let's just separate out for some. This for R1, this for R2. So this one I already calculate my R new, okay, is this. So 104 you want to put inside. So we get 104 this L over pi d squared. Okay. So this is a mathematical way. All right. So from that volume equations, I can find the new length for the wire. And I'm going to put the new length into this R2. Once I have this, what I want to do, okay, get this out of the way. Okay, over here, right? You want to put R1 over R2. Okay, so this divide this, so you should get this divide this. Maths, right? Lots of maths. I know. Okay. Sounds like this is a maths lesson right now. Cool. So we're gonna cut this two thing. Okay, mathematic again, cut. Okay, 4/1/4. Okay, do your maths thing. Okay, cut. All right, 4 divide 1/4 is just times 4. 16. 16 is gonna be here. R1/R2 is gonna be 16. So R, okay. So how many factors decreases? So you can see that R2 you move over is 1/16 R1. So basically, my new resistance is gonna be 16 times smaller. Okay, because that's your R1 divided by 16. So yeah, so that's it. Okay. Okay. That's it. That's the max. Okay. So use the formula and you can solve it. Okay, I understand this question is exceptionally hard, okay, because of the maths. But yeah, you have to be good at maths. Okay, for those who love maths, you're gonna love this because this one looks something similar to the geometric series, right? You know, okay, if teacher Steven teach you guys, okay, geometric series. Okay, sorry for those who didn't take maths, okay, but that's how it goes. That's just pure algebra. Okay, so yeah, this question is tough. Of course, there's a lot of students ask me this, so yeah. So that's my method, okay? I employ this method. Of course, if you look at other textbooks, they employ different method. But most of the time I teach this method, you know why? Because by the time you go to A level, right, things gonna be crazier. So if you get used to this method, right, then save you some time. Okay. All right. So moving next, this over here. So time is 160 seconds, 2 minutes. Resistance is 3. Okay, I'll get straight to the point. How much energy is transferred? Okay. Okay, so power is equal to energy over times. Power is equal to IV. Okay, substitute both together. IV equal to E over T. Okay, energy is equal to IVT. All right. Use these two formula. Okay, how you know? You just need to know. Okay, so I is, oh, I don't have resist. Oh, my bad. Since I don't have the okay, never mind. We just rearrange this again. Okay, so this one, right? Okay, since I don't have this, I can use another one. So power is equal to V squared over R. Because I were given R, V and R, so that's another way you can do it. So V squared over R, okay, equate them. Okay, so your E is equal to V squared over R times T. So that will be 12 squared over 3 times 120. How much is that? 5760. It works. Of course, if you choose to calculate the I using V equal to IR is fine, and then you use P equal to IV is fine too. Okay, but I like to be more straightforward. Because you have 3 power formulas, if you still remember. Okay. P equal to IV, P equal to V squared over R, and P equal to I squared R. 3 formula to calculate power. Okay, so the rest I'll just skip a bit, wait. This one more or less the same thing. Okay, over here, okay, let's talk a bit on electromagnetic induction. Now you remember, right? I mentioned before, okay, you have your right hand and you have your left hand. You just have to memorize, all right? Your flaming right hand rule is what? You are inducing current, you are making current, right hand. Okay. If you are supplying the current, okay, you are using the left hand. That's it. Left and right. Memorize one, you can memorize the other one, right? Oh, right is induced current, and then the other one must be supply current. Okay. So we look at this case. Now the keyword should be simple already. Induced current. Okay, sure, it's the right hand because we are making current inside. Kind of like making current, producing current. Okay. So I know that I'm going to use the right hand rule. Okay. So for those students online, okay, just point accordingly. Okay. North to south. Okay. So first take your index finger. Okay, you are pointing to the right because your south is to the right. So north to south. Okay, kind of pain, but just bear with me. I'll be a bit flexible with your hand. Yeah. Okay, now next, there's an induced current moving from X to Y. Now, if you look from the monitor, X to Y is here to you. Okay. Now I can't really. Okay, so bear with me. Okay. So yeah, it's north to south, and then it's coming out from X to Y. If you kind of sustain your position for a bit, you can see your thumb is going down. Okay, so that's your donkey. So you move down. Okay, that's it. I mean, can you do it? Hey, can right? Hey, like this, or can like this? So north, right? This, okay, you have to, yeah, like this, yes, yes. Can, right? North, okay, hey, wait, give me X, Y, yeah, X is quite, yeah. Okay, you got this? Okay. All right, can, okay, should be okay, okay. Just use, okay, you have to be more flexible with your hand. Okay, there's no other way. Of course, you can choose to memorize it, but I don't recommend that. Just play around with your hand, move it a bit, okay? All right, over here. Okay, so for AC generator, if you look at the graph, it's gonna look like this. Okay, it looks like this. Okay, so over here is half turn. And then over here is one complete turn already. Okay, over here it says that from 10 to negative 10. So this is 10, this is negative 10, right? So I turn how much already? 180 already. Because the total angle from here to here, right? From all the way from here to here is 360, right? So if you look at from the highest point to the lowest point, it's half of the whole process, right? Half of the whole process is 180. Because the total process is 360. So we convert the time into angle, that's it. That's what we are doing. Okay, so the answer is B. Okay, transformer, the easiest question of all time. There's one tough question, okay? Some of you asked me last time, right? So we just settled that for you. So over here. All right, so here, this is the formula to be used. Okay, so you're gonna calculate with this formula. So over here, you want to put in the equations. So your input voltage is 240. Your output voltage, I don't know, just Vs. The MP is 800. Okay, and the NS is just 40. Okay, so VP is your primary voltage, Vs is your secondary voltage, MP is your number of turns for primary, and NS is your number of turns secondary. Put everything inside 800 divide 40, and then 840 divide this, you get 12. Okay, so the answer is B. So definitely I know my voltage is lesser, which makes sense. Why? Because this is a step down transformer, right? Because the number of turns is lesser on the secondary side. Okay, whether the decay, yes, I'll show you the important one. Okay, look at this over here. Okay, if you look at the question over there, okay, so radioactive substance, okay, undergoes alpha decay. So let's write it out first. The easiest way is to draw it out. Okay, it say that alpha decay is 4.2, right? Okay, maybe give up something where I put X. Now, if you calculate mathematically, right, how much is this? So it's 218 minus 4, right? It's 214, right? And how about the bottom one? 84 minus 2 is 82, right? So this alpha decay. Now, alpha decay, you need to memorize 4.2, definitely. Because the proton is 2, while the nuclear number is 4. Okay? So you say that, hey, this further will undergoes another decay. So this further itself will undergoes another decay is beta. And maybe I come up with Y, it doesn't matter the symbol anyway. So 214, and since it's minus 1, so it's going to be 83. Because 83 minus 1 is 82. Okay, so remember, the right hand number must equal to the left hand number. Okay, so you get this one, what is the nuclear number? 214 and 83. So let's see. This is the final answer. So 214 is 83. So draw it out first, easier to see, right? So try to draw it out and look at what is the suitable number. Okay, divide 2000, how much you get? Okay, so it's 2 over 5. So 2 over 5 is 0.4. So the answer is A. End of story. Okay, use the formula. Be careful with the prefixes. Okay. All right. Then this one, nope, this one is not so important. Okay, let's look at the reflection of light. Okay, memorize this, by the way. Okay, there are a few cases you need to be aware of. Okay, remember this. Okay, you just have to remember to flip the formula. So this is sine R over sine I. Okay, now this is when you have water moving from the light in the water moving into air. Okay, but if you have the light ray moving from the air into the water, right, it will bend nearer definitely. Use this formula, please. Sine I over sine R. Okay, of course you memorize this one, but by the time you come to this case, moving from water into air, please flip the sine R over sine R thing. Okay, so these are the concept. Right, moving on. Okay, now if you look at this example over here, so now this one, okay, some of you asked me before. So since this one is moving from less dense to more dense, we're gonna use sine I over sine R. Okay, so that'll be for the second case. And but at the same time, I know that V1 over V2. Remember the formula? The speed of light in air over the speed of light in medium. Or you can say speed of light in vacuum also can, okay? It's the same thing, okay? So it's gonna be the same thing. You put in the value sine 55 over sine 33 over V1 is 3 times 10 power of 8 over V2. Okay, so just flip it, okay? So sine 55 is how much? Divide sine 33 and 3 times 10 power of 8. Divide this. Okay, you should get 19999 something. I'll say round it up, you get 2. That's it. Okay, so remember, this is the formula. N can be equal to sine I over sine R, but N can also be equal to the speed of light in the air over the speed of light in the medium. Okay, remember the formula for this. Okay, so over here, no, that's the same thing. Now, these are the cases I would like you to emphasize also. Okay, you can take a look. Okay, so look at these few cases over here. So over here, we have refraction. Now, when refractions will occur, now imagine over here, we have the light starting in the water itself, okay, or glass block, whatever suit to you. As long as it's in a denser medium to start with first, okay? So in this case, my angle of incidence, by the way, this is the angle of incidence over here. Now, if your angle of incidence is smaller than the critical angle, the light will not go up. Okay, the light will go up, my bad. The light will not stay inside, so refraction will occur. You just have to know the cases only. If it's equal, then this thing will go 90 degrees over here. So that's for the second case. And for the third case, if your incidence angle bigger than the critical angle, it will not go up. It will be total internally reflected as this. So memorize these 3 cases, okay? So yeah. So in exam, will ask you on this, okay? So make sure you know these 3 cases first. Once you know these 3 cases, the question will be simple. Okay. So over here, you can see. Now let's compare. Look at the question. Okay. Of course, this one, they kind of slanted halfway. You can kind of look like this manner. And you can see that it is 90 degrees. So this will be the second case over here, right? Second case at the middle. So I know that that happens when my I equal to my C. Okay, but do I know my C? Okay, he said that initially this is a speed of light, but by the time it go inside, the speed of light is 0.8. Speed of light in the medium. So can I calculate my N? Okay, so that's a C over 0.8 C. Because V1 over V2, right? So you cut 1 divided by 0.8 is 1.25. Okay. So I know that the formula 1 over sine C, right, to calculate the critical angle. So 1.25 equal to 1 over sine C. Now you just move around your calculator, okay, and find the C value for me. 1 divided 1.25. And then it's 53, I mean. So that's 60. Okay. So you need to know the cases first, definitely. Memorize the 3 main cases first. Then you can solve this question. Okay. Yeah. So after that, let me see. Ray diagram. Yes, let's talk about ray diagram before we end the workshop for today. So ray diagram, you need to know 3 cases as well. Okay. Now drawing, of course, you can practice at home. These are the 3 cases. Okay. You need to know how to draw even in paper 2 because sometimes drawing can help you. Okay. And you need to know the property of the image. Okay. If you can memorize it, that would be very good. Okay. If you cannot memorize it, drawing is your second best choice. Okay. So this will be the 3 cases. And just look at one example over here. All right. So in these cases, we talk about camera. Now, camera is going to belong in the first cases. Okay, where the image definitely is smaller. You can't be the image is bigger than the object, right? That'll be scary. Okay, so the image in the camera must be smaller. Okay, and you can see image in the camera is an inverted image, the real image. Okay, it's smaller and it's inverted. Okay, so the only possible answer is A, smaller and it's upside down, inverted. Okay, so the answer is A. The rest is not hard. Okay, so that's our workshop. Okay, we still have a few more questions where we can settle it. Okay, so for our next workshop in the coming week, we'll focus on paper 4. Paper 4, we'll talk about how to answer the question first, because most of you need help on how to answer the question. For paper 6, okay, we will emphasize on the technique on the graph. Okay, and the question number 4, the planning of experiment. Okay, any question for today? No, that's it. See you guys. Bye bye.